Well, that said, I hope you guys are ready to have a good time because this is a great conference for everyone. Right now, we have Product Development Manager, Scott Wilkerson. So if I could have you guys put your hands together for Scott. He'll be talking about log monitoring management and analysis with Nagios.
I don't need that. Thanks, Paul. Well, welcome, everybody. It's a pleasure to be able to be here today on the 15-year anniversary of Nagios to introduce a new product, Nagios Log Server. Today, we're going to get started by kind of giving you a high-level introduction to Nagios Log Server. We're going to cover some of the key features and benefits, and then we're going to walk into some demonstrations so you can see the new product in action. To give you a little history about myself, again, my name is Scott Wilkerson. I've been with Nagios for almost 4 years. This is my third Nagios World Conference, and I come to each World Conference with a new title. I've been the support manager, IT manager, but in the last year, I've had the opportunity to focus on product development management, and it's given us the opportunity to bring several products into market. We brought 2014 Nagios XI out in the last year. We brought Reactor into beta mode in the last year. We released 2014 Fusion, and today we get to take a look at Nagios Log Server. So what is Nagios Log Server? Well, it was inspired by a session that we had at the 2013 World Conference, where we allowed attendees to sit down with myself and Ethan Gallstead and give us some feedback on items that they'd like to see. One of the items that came up was we'd like a way to be able to process log data, create alerts on it, and during that session, we formulated the specs for a product, and that product became Nagios Log Server. Nagios Log Server is a central log collection and analytics platform. It gives you the ability to send log data from a whole array of systems, Windows systems, Linux systems, network devices, et cetera. And these get streamed into Nagios Log Server, and you can take the data that comes in and either visualize it any way that you want, or you can create alerts, like security alerts, have them automatically deployed out to your monitoring solution, or you can have them sent via email, run a custom script, create a Nagios Reactor event chain, et cetera. So you can monitor security logs, application logs, development debug logs, setup logs, et cetera. And we can take that information, store it in one central location, and have the ability to retrieve it at any time we wish. In addition to that, Nagios Log Server is set up with a clustered architecture, so you have many instances that create your cluster. That gives you the ability to distribute the workload, taking the data and splitting it up into a primary shard and a replica shard. And this gives you a lot of speed, power, and reliability. It gives you the ability to take your data, have a replica copy of it, and in case of failure, you have the ability to just still access the instance through the replica data. Nagios Log Server makes big data useful. I read once that big data is anything that's too much information to fit in a spreadsheet. Wikipedia describes big data as an all-encompassing term for data that is too large or too complex for traditional data processing applications to manage. So we built Nagios Log Server with Wikipedia's definition in mind. Nagios Log Server is a commercial product, but it has open source roots, as Ethan mentioned earlier. We built the product on the Elk stack, first comprising of Elasticsearch. Elasticsearch is the data store that we use to index and search data within Nagios Log Server. Elasticsearch itself is built on top of a project that is now known as Apache Lucene. Lucene was first created in 1999, the same year that Ethan Gallstead committed the first code for NetSaint. In 2002, the same year that Nagios was, NetSaint was turned into Nagios, the Lucene project joined the Apache project. Elasticsearch has a bunch of distributed capabilities which we take full advantage of in the Nagios Log Server product, giving you the ability to have high availability, redundancy, and extreme speed. So to collect the logs and get the information into your Nagios Log Server, We use Logstash. Logstash is a collection platform where you can send data from a wide array of inputs. These can be TCP sessions. You can stream file data directly from any system right into Logstash. And the developers of Logstash, at least the primary developer, has some benchmarks that they've done. Actually, this is some old data. But they benchmarked a single Logstash instance with the capabilities of processing upwards of 100,000 messages a second. So we found that would be a really good solid foundation to be able to pump logs in and really get them in fast. And as Ethan mentioned earlier, we also took the opportunity to take the Kibana interface that is also an open source project and integrate that directly into Nagios Log Server into what you'll come to know as the Log Server dashboards. While Kibana did have a full feature set for the most part, it was lacking some things that an enterprise solution would require. And as Ethan again had mentioned, authentication was a primary item. So our developers made quick work to make many modifications. We use a highly customized version of Kibana, which gives us the ability to have user-based dashboards. So you can save the dashboards and display the information the way that you'd want to see them. Whereas your colleague may want to display their information in a different format. You might like bar charts, while Tom might like pie charts. So you can each create custom dashboards. But we built in the ability to share these dashboards with individual users or globally across the whole system. In addition to that, we also had to add in alerting capabilities because our primary product really deals with alerting people for when events occur. So alerting was something that we knew that enterprise people would definitely need. So in Nagios Log Server, we really have the ability to feed in any textual data. And while Windows event logs may not actually look like textual data, there's a lot of data there that can be extracted out and exploded apart into Log Server, giving you fields that you can search on. In addition to that, you can stream really any text log file from Windows systems or from Linux systems very easily. Nagios Log Server gives you the ability to do infrastructure-wide query and analysis. And what I mean by that is, as opposed to on your Linux system, if you need to look to see if there was a particular event, such as failed logon or 404 pages if you're looking at Apache logs, Nagios Log Server gives you the ability to stream all of that data into one central location. And when you run that query, you can see how many of those events are on any of the log sources that you're monitoring. So you may have 50, 100, 200, 1,000 web servers. And if you want to see what items have 404 or 500 level errors on them, you can get them all, drill down, and see which ones are of the biggest concern at that time. We have automated alerting based on any search pattern. As you use the easy user interface, you can create your custom queries and filters drilling down to the detailed specifics that are important to you. And decide at that point, if I want to receive an alert on this, I simply click a button and I'm presented with this screen where we can create a custom alert specifying the interval that we want to check for the quantity of items that are being returned, how far back we want to look in that count, set the thresholds with regular Nagios standards, and then choose the alert method we want to use. Do we want to send it to a Nagios server? Do we want to create a Nagios reactor event chain? Do we want to send it via SNMP trap, or just simply send an email? All of that's built into Nagios Log Server. We also added in the ability to automatically archive historical logs. For compliance reasons, many organizations have to keep their log data for a specific period of time. So system logs may need to be kept for 2 years, or 3 years, or 5 years, depending on your industry. So we made this very easy to set up in Nagios Log Server. You simply set up a repository on a shared file system once within your cluster, and all of your data is automatically archived every single day. Those archives can be restored and brought back into the system to be searchable at a later time if you so choose. Nagios Log Server is distributed by design. As I mentioned earlier, Elasticsearch is built to be distributed by nature, and we took full advantage of that feature set. Adding an additional instance into Nagios Log Server cluster is as simple as running a full install script or spinning up one of our pre-created VMs. You spin up the VM, you enter your cluster ID and one host name, and you have a distributed architecture ready to go. Elasticsearch, which is the backend data store for Log Server, is scalable to petabytes of data. While it came out of a 4-year, petabytes of data, excuse me, while it came out of a 4-year beta period, Elasticsearch has proven time and time again to be a very, very reliable data store. And as a matter of fact, most of the Fortune 500 companies use Elasticsearch in one capacity or another to be able to index their data. This data scales extremely well because by adding additional clusters, we are able to split the workload across all of that to various elements in the cluster. It's very easy to configure. As I mentioned earlier, individual users can create their own custom dashboards to display the data however they want. You can save these dashboards, you can share them, and you can also export them very easily right from the Save menu. Queries are the same way. As you search and filter down your data into items that are useful, you can save that query for later retrieval because you don't want to have to write the query every single time that you go in to analyze the logs. You at least want a base to start with of something that you've done in the past. So you can easily save these queries, bring them back up, and you can apply any query to any dashboard. So while you might want to visualize your data one way, another member of your team may want to visualize their data a little bit different, and they can run the same query across a different dashboard. Data is available within Nagios Log Server in near real time. Generally under a second, 5 seconds is about the maximum time from the time the log event occurred to when it's available to be viewable in the UI. It's fast. I mean, the backend search is fast, creating dashboards is fast. It's just fast all the way around. When I say it's fast, I mean we're talking milliseconds to query data in data sets of the quantities of billions or trillions or more documents. You can filter that data down to the elements that are important to you and receive the results back from your whole infrastructure in just milliseconds. And yeah, it's really, really, really fast. When you all get a chance to take a demonstration of Nagios Log Server, you'll see that it's really quick to get the data back. The data can be set to automatically refresh as it streams in. So you set the time period up to show me, say, for example, the last 5 minutes of data, and I want it to automatically refresh every 5 seconds or every 1 second. And you see the data stream in real time. Because it's so fast, I decided that it would be a fun experiment to give back something useful for everybody that attended today that they can kind of take with them as a demonstration of how easy it is to set up one of these fancy custom dashboards like you see up there on the right. So what I did is I set out to create a 5-minute dashboard. And I created a video and recorded the whole thing, but here were the specifications. I started out with a fresh install of Nagios Log Server. I added a filter section in the GeoIP filters, which I'll kind of show you where you can add those later. And it looks like this. It basically says in the filtering, this is a Logstash filter configuration, but it says if the program is marked as Apache Access, we're going to apply the GeoIP filter to the client IP address field. And that's going to take your client IP, run it through a GeoIP database, and explode that data out into country, region, city, latitude and longitude, et cetera. And then we're going to add all of those fields into the data so we can make things useful. Then we started sending the machine Apache logs. And I actually created this on our live server on the machine that we're actually using in our infrastructure, streaming in our data logs so we can get some insight into what's going on in our Apache logs. So we're going to walk through. We have a video here. So we're going to hopefully roll. Here we go. So we're rolling the video. So I'm starting out with a default dashboard. This is a default view. And we're going to drill down, and first we're going to limit this down to just be Apache logs, because that's what this dashboard is all about. It's about our Apache logs. And then we're going to take the log sources that we're sending in. We have several log sources. And as I go through the video and as it plays, you'll see I'm human, and I make mistakes. And you'll see me revisit and go back into the configuration to modify things, tweak them the way I want. I'm changing some items from bar charts to line charts. It's just a couple of clicks. So we changed some visual elements. But what I'm going to do right now is I'm actually going to switch this to give me just a little more depth in my view. And we'll save that. And then we're going to actually convert this, what was an events over time chart, we're going to convert it into a bandwidth chart. So I'm going to, instead of just giving me an account of events, we're going to grab the total of the quantity of the bytes that were in our logs, or in our log data. So now I have a bandwidth graph that's fully functional. Over here, we're modifying the different fields that display in the columns, because what's important for, say, for example, an Apache dashboard is like maybe what the response code was, what the request URI was, et cetera. So we modified that quickly. Now we're going up here, and I'm going to make some quick changes because I want my graph to be just a little bit smaller. And then I realized that we'll make it just a third of the screen. Later on, you'll notice that I rename it to bandwidth, which I haven't done yet. But now we're going to add in a quick pie chart, and which is going to give us a pie chart for the response. So if we wanted to drill into any item, so we have our pie chart there, we can simply click on any element within the response, and it will automatically filter our data down to just the items that are important. So for example, if we wanted to see 404 errors, I just click 404 item in my pie chart, and it'll automatically drill down that data. Everything within the UI is draggable and droppable, so you can actually drag the items from one side to another. You create different rows within the interface, and you can assign certain elements to the rows. You can drag items between the rows, et cetera. Here's where I rename it to bandwidth. See, I said I'm human, I make mistakes, so I forgot to name it the first time. And now I had already eliminated the events over time, which I previously had, so I'm going to go ahead and add a new panel in here, and it's going to be a data histogram, and I'm going to re-add the events over time back in. So this is just going to give me a count of log events that have come in, and that's where we have the bar chart. It's kind of scattered there, so I'm going to make it a larger time window, so I'm looking at 30 minutes in each bar instead of just a minute there. So now we got some visual data. I'm collapsing some of these rows just to kind of clear my palette there. And then we're going to add in another row that's going to, that's going to just give us a list of the different sources that we're receiving these logs from. So these are Apache logs. We have several servers. And I'm just going to make a quick bar chart and stick in that row to give us the ability to drill into any of the specific servers that we want. So I simply collect my log source, choose the bar chart, and it's going to automatically put that in there, and I'll drag it right into the field that I want. Now is where the cool stuff begins. As soon as this gets done, we're going to go ahead and add some visual elements with about 3 clicks. So now we have the information there. We can see that we have our bar chart. We're going to go ahead and, again, shrink these or collapse these down just to kind of clear our palette, and we're going to add a new row for maps. Because visualization's cool when you can put it in a map. So we're going to add a maps row, set its height for the row, and then we're going to add a panel that's going to first create a USA map. And as you remember earlier, I had mentioned that we took the log or the client IPs that were coming in, and we exploded that data out into GeoIP information. So I can take the IP and split it up by region. And in the United States, the regions are the states. So we're going to also add a second map, and this one's going to be a world map. And in the world map, we're going to split it out, putting in the location, which is the latitude, longitude. That'll plot us some groups. You see in the field here also we have a max points. Because you may have tens or hundreds of thousands of different points, this is just going to give you a condensed view. This is going to give you a targeted view based on the quantity of points that you put in there. So now we have a map that we have in there that you can actually click on and drill into specific information. If I wanted to see only requests from California, I simply click California on the map, and it will filter everything down. So now, as I had mentioned before, if you want to filter items down, you simply click on 404, filters everything down, just displaying us the 404 information. So everything's starting to look pretty good. There's a high-level view of this 5-minute dashboard I created. What we can do is we can remove the filter before we save it. And we're going to go ahead and save this dashboard and make it globally accessible to everyone within our organization. So I click the little drop down. We'll name it Better Apache Dashboard. And then we're going to click the little global save, the globe icon on the right-hand side, and we'll go ahead and save that and make it available for everyone in our organization. And I'm going to actually make this dashboard available for everyone here as well. It'll be available on the Nagios Exchange, so you can all download it and use it within your infrastructure. And there we go, you can log right in. Additionally, there's easy time filters that you can filter any data down, as I had mentioned, only showing the last 15 minutes or week, month, year, however long you want the dashboard to display information for. So what does it take to set up Log Server? Well, it comes pre-configured with a bunch of inputs and filters already built into the system. And as far as I know, from a Logstash standpoint, the configuration interface that we've created is the only GUI-based Logstash configuration available. I've never seen one, and so this is the only one available, which is really neat when you get to play with it. Because certain items are actually order-specific, it's nice and easy. You can drag and drop the elements to order your filters to make sure that they happen in the proper order. You can simply add individual fragments. But the best part is, when you save and apply your Logstash configuration, it actually deploys that configuration out to every single instance within your cluster and automatically starts using that. So if you set up a clustered model and you have all of your instances within the cluster, maybe using a round-robin DNS or or some type of IP routing situation, you can send all of your log information to the host name for the round-robin DNS, and any of your servers can pick it up. So this is actually a really cool feature. We also have just a nice, easy-to-use cluster status interface, which gives you the ability to get a high-level view of all of the elements within your log server cluster. So we can see how many documents we have, how much data is being used within the cluster, and how many data instances we have logged in. One thing to note is we have a status of yellow on the screen here. The reason for that is we only have one data instance deployed. There is no backup. There is no high availability. So we're kind of in an alarm state. Like it's still fully functional, but we should spin up another log server instance to be able to take advantage of the high availability and redundancy. We also have an instance management interface where right from this view you can see what the 1, 5, 15-minute load is on a particular instance. What's the memory utilization? How much disk space do we have left in our cluster instance before we run out? We also have complete index management built into the system. You can open, close, delete indexes, and the indexes are what Log Server uses to store the log information. It creates a new index for each day, and it's kind of on a rotation. So these get optimized as they no longer are receiving input, and the individual indexes can automatically be archived. And then we have automated backup management. As I mentioned earlier, it's very easy to create archive data for compliance reasons in Nagios Log Server. We simply add in a repository, specify how long we want to keep the logs for, and it automatically takes care of everything else. Every night it'll automatically take a backup of all of the indexes we have in the system, store them off-site for later retrieval if we need to go back and look at something in the future. As we mentioned earlier, it's distributed by design, which gives you some redundancy. It's kind of like as Ethan mentioned, as you bring on additional instances, it's kind of like a software RAID, where it breaks the information up into shards and distributes those shards out to individual instances in your cluster. But all instances in the cluster get to share in the workload. So when you're performing a search or a query, it routes the information to the specific instances that are pertained in that query. So if you have a 5-instance cluster and all of the information is stored on just one instance, it only hits that one instance. Or it hits one shard on one instance and another shard on another instance, collects the data back, aggregates it, and gives it back to you. So I put together a little quick video to kind of show you how this works when you bring additional machines online. So in the dark green boxes, we had the primary shards. And this only has one instance up currently, so we had the unassigned shards in the gray. So we're going to add a second server and show what happens. As soon as we bring the second server online, you can see we automatically are replicating all of the data over to the second server. From this point forward, both of those machines can respond to search queries, and they will automatically start indexing. When we add a third server is when things really get interesting, because some of the primary shards are going to move, and some of the replica shards are going to move, and we no longer need to duplicate the data, right? Because we have one backup of each of the primary shards, that is the replica shard. So we can kind of shuffle the data around and distribute the workload across the machines. And we can add as many machines into the cluster as we want. As we add a fourth machine into the cluster, the same items happen. The data gets distributed across, some of the primaries move up, and we're just kind of spreading the data and thus the workload across all four machines in the cluster. The common next question is, what happens when a server fails? Well, when one of your machines goes down, all of the shards that were assigned to it are no longer available. So Elasticsearch will automatically redistribute the shards within your cluster to the available machines, and it does this in real time. When another machine fails, again, all of the, if a primary shard goes down, the secondary or backup replica shard becomes the primary and then copies the data over to make a replica of itself. So now we're getting to the point where the third machine fails, which is going to bring us back to where we were when we started. Nagios Log Server with one instance is still fully functional. However, you do not have the high availability and the backup. And hopefully, your Nagios monitoring solutions alerted you by this point. So as we mentioned earlier, we're going to have a little contest. And Ethan mentioned that we extended the trial period out 90 days for this. And it's because the contest is going to work like this. As I mentioned, it's really easy to create custom dashboards. And everybody's going to want to download Log Server, try it on a VM, play with it maybe before they decide to roll it out in their infrastructure. And while you're doing that in your trial mode, you can create custom dashboards and export the JSON file. And you do that right from right under the Save menu. There's an advance, and you can export the JSON. Well, as a community, Nagios thrives because other community members share the things that they've created. Now, I'm not talking about sharing sensitive data, but cool dashboards doesn't equate to sensitive data. You're not sharing your log data, you're just sharing the cool user interface that you've created. So if you export a dashboard that's super cool and you upload it to the Nagios Exchange, there's going to be a link in the PowerPoint, but we also have information available at, it's kind of hard to see, but it's nagios.com/products/Nagios Log Server/contest. You upload it to the Exchange, and the winner will receive a choice of either a 5-instance Nagios Log Server license or a $500 Amazon gift card. Because if you're not the one that has to buy the Log Server license, you probably want the gift card. So it's as easy as that. The contest is going to run through December 31st. And so the 90-day trial, at least initially, will push us beyond that. So you can participate in the contest while you're still in your trial period and have a chance to win before your organization purchases it. So as I mentioned, we have a 90-day trial. You can download Nagios Log Server at nagios.com/download log server. Additionally, I want to mention that at the demo tables, they're actually going to have copies that they can put on the USB flash drives that you guys all received in your bag. So we have copies of the pre-created VM instead of clogging the hotel's Wi-Fi access. The images are kind of large. They're probably about almost 600 megs. So they'll copy them onto your flash drive for you if you want. That'd be great. And we did do one other special thing, and that was because Log Server did kind of come out of the information that we gathered from the members in the previous World Conference, what we did is we put together packages of earbuds. And they're Nagios earbuds. They're really cool. They have a little N on the side. But they're in packaging that basically says, you asked, we listen, Nagios Log Server. And so you guys can all pick them up at the demo table as well. And one final note before I break for questions, I saw a big flood of people run over to the demo machines. Those demo machines are super cool touchscreen machines, but it took a long time to prepare all of our products on them. And some of the information that you see on Log Server, they're going to try to get an updated version, but some of that is actually about 300 revisions ago. We have about 400 hours, man-hours of development that went into the actual release. But we wanted to be sure that we had the demos ready before we actually released the product, which was about 15 minutes ago. So with that said, I'll open the floor up for any questions. And one quick point for the questions, let's make sure that we have one of our guys able to get a microphone before the question gets there. Yeah, just raise your hand and they'll go ahead and bring the mic over and we can get it on tape.
Hi, I'm just wondering, if we have an existing elk stack deployed, do you provide a method to migrate your data into Nagios Log Server?
That is an absolutely fantastic question, and I'll say we would love to work with you to help you do that. Part of it would be very easy to do. So if you have an elk stack deployed, it's not going to be quite as straightforward as just spinning it up, but because we have to change some things that we depend on. But we absolutely would love to work with you on the complete solution. One thing that I will mention, and I can probably go back. Maybe not. Maybe this is a one-way thing. On the configuration, so if you have an elk stack previously deployed, and I showed you we had the cool centralized configuration stuff where you can just put in your config fragments, those are straight up Logstash configs. So if you've already done some work creating an elk stack, you actually can just grab all of your inputs and stuff them right in an individual field, or you could bust them up into fragments. The same thing goes with the filters. You can kind of name them and group them with our system, whereas otherwise dealing with Logstash configs alone is just, it's like text files. They're very similar to Nagios core config files. I got a question, a couple over here.
So what's the advantage of Log Server versus just Elasticsearch elk stack out of the box?
Were you here the whole presentation?
I know. Like, give me the.
So the biggest.
I know.
I'll give you
the short.
I'll give you the short version. The biggest key advantages are you're going to have the ability to straight away create alerts from the items that you query. You also have the ability to create user-based dashboards. A straight out of the box elk stack is it does give you the ability to save dashboards, and then everybody gets to see them, and everybody gets to use them, and everybody gets all of your dashboards and the stuff that they want to see. So you get to save user-specific ones. You do have an option to save them globally so other people can take advantage of that. So that's one of the features. Another one is the ability to save queries. While you could save a whole dashboard with an elk stack, you can't save an individual query and apply it to another dashboard. So that's another key feature. Probably the biggest thing that I would say is the automated cluster management, whereas we can deploy the configurations, handle them either on a per instance or a global on a global basis. So there's quite a few different options in there.
So we use a commercial product right now. I was just wondering if this will eventually import like the metrics from Nagios, so you could compare that to your logs. The answer is yes. Okay. You can do it straight away. It'll take just a little bit of configuration, but you can stream the data straight in from like Nagios XI. In addition to that, I didn't even mention this does fully integrate with Nagios XI, and so we have plugins and configuration wizards. So you can actually create a query here, and from Nagios XI, you can have it create an active check of that query. In addition to that, there's a plugin that you could use to query via core, or you can actually send the query right to our backend API. There's a fully exposed API for the the equivalent of Elasticsearch API, but we've actually added authentication on that as well, which is another key thing. There is no authentication built into Elasticsearch, so we added API access, individual user accounts, individual users API. In addition to that, there's also an audit trail that we built into the system. So you can see who searched for what, or who did what, who changed the configuration. All of that is not built into the typical Elk stack.
So do you have true multi-tenancy with different indexes that have access controls per tenant?
No, this is not a multi-tenant. It's a multi-user application, but it was not designed to be multi-tenant. So different organizations would not want to share an individual cluster. What I would recommend for that is deploy 2 clusters.
I understand there's, on the machine that's generating these logs that you've been feeding, there's an agent running on this side.
Maybe.
Well, okay. So in the case that there's an agent, as soon as our security guys hear there's an agent, additional agent running, they're going to want to know what securities are built in it.
Sure.
What about that?
So it kind of depends on the types of systems that you have and how you're sending your data to Log Server. It can receive the data in many different forms. On Linux systems, the standard that we actually recommend in our quick wizards generally send that data through syslog. So if you have our syslog running on your system, it actually will send it via a TCP output from syslog. And the same with streaming any text log file from a Linux system, you can send them all that way. That's one mechanism, but there's a lot available. On Windows systems, it's a little bit more challenging because you need a mechanism to be able to read into the Windows event log. And so our recommendation for that, although there's lots of ways to do it, is we recommend an open source product called NXLog. It's a very lightweight, and it just streams the data out to a TCP port on Log Server.
Where were you when I was setting up the ELK stack months ago?
Well, if you still need some of the features, again, just like the gentleman over here I'd mentioned, we'd love to work with you to help you convert it over so you can take advantage of some of the features in Nagios Log Server that aren't present in the Elk stack. I think it's very possible to perform a migration, although we would just want to be careful that we don't, that we take care of your data, because we don't know how your Elk stack's set up, and we don't know what type of backups you've previously created for in archiving and whatnot. So,
but my actual question is, if you've already deployed Lumberjack, or if you've already deployed whatever Logstash configuration shipper,
yep,
can you still use them?
Yes. So that is a great question. So for those in the audience and anybody that watches the video in the future, great question. So we use Logstash completely unmodified. It's the latest version. It's version 1.4.2, which means anything that can ship logs to Logstash can ship logs to Log Server. So if you have Lumberjack, Flume, there's literally dozens and dozens of inputs and filters, and all of them are available in Nagios Log Server. So the only difference in your situation is you would need to be sure that the host that you're sending the logs to becomes your log server's IP, or it gets changed to, and straight away it'll work right out of the box. Yep.
I don't know a lot about Logstash. How does it handle Java logs, just stack dumps and that sort of thing? Good? Awesome. Excellent.
It actually has a log4j input that you can actually feed them, and you could also Logstash actually runs it runs in Java, and so because the developers have developed it in Java, they actually find that very useful to be able to debug their own logs.
I was just wondering what you use for your message broker in your setup.
That's another great question. We don't straight away. However, you can design your setup to be however you want. So the items that come into the instance for like the logs that come into your instance of Log Server, they're being fed in one way. You could add an input that is in fact a message queue or a message like a Redis broker, and you could feed your items from any of your external systems into that, and then read that input right into Log Server. So we've abstracted that out. That's not part of the design, but you have the ability to feed it into whatever is the one that you prefer to use. And then you can read those inputs right from within Log Server. Does that answer your question? It
does. I just wonder what happens to the messages that might get lost.
Well, hopefully they're not going to get lost. But generally speaking, for the typical setups for like our syslog setups and on Windows machines, the NX logs, you can actually have your system spool. So the recommended configuration comes out where it will spool the messages and send them as soon as it has the ability to connect. And if you set up like a round-robin architecture or something like that, even if it couldn't connect to one machine, it'll connect to the next one or the next one at its next cycle.
I got a question for you.
Where are we at?
Back here.
Sorry.
Does the window event logs, do they get truncated as far as character size or anything? Because I've got some developers that want to get some event logs, but they want the full stack trace.
Yep, it's all there. No truncation. These are your logs, so the data's complete. And as a matter of fact, I don't have a slide for it, but it's really neat how event logs come in, and it takes the data that was in event log and actually makes it more useful than if you were using the event viewer on the Windows system itself, because it explodes all of the data into individual fields that you can do really cool things. Like you just click one button, like I don't want to see any messages that have this, or I do want to make sure that the items contain this field, and it's just one click. But you can filter it down to any element that you want.
I noticed on one of the slides that when you create a user, you could give API access.
Yep.
And what all can you do with the API? Can you do all the configurations that you mentioned for management?
Great question. No, not yet. So you can't create configurations through the API, but you can read all of the data available through the API. So yeah, not yet, but that actually would be on a good feature to put on the to-do list.
Okay, you showed on the dashboard a world map and a US map. Can you create custom maps, maybe your server room, so you can see what servers are actually going out?
Not built in, so where you were putting you're talking like the equivalent of Nagviz in the panel?
Kind of, yeah.
Okay, not built into the system, could be a possible feature. It does have areas or panels that are, they're like text areas, so you can enter like HTML in there. So you could actually conceivably load a Nagviz map into there, but you'd have to be passing data to it, and that would be somewhat complex. So there is the ability to do some customization, but there isn't any like Nagviz-y type maps in there.
Over here. We're using Nagios XI and Network Analyzer, which Network Analyzer doesn't have Active Directory integration. So does the log server have Active Directory, or is it going to? Because having 3 different logins can get irritating.
I'm with you. Having multiple logins is irritating, and that is, I know for sure, on our to-do list, not only for log server, but basically the whole product suite wide. We want to develop sometime in the near future the ability to centralize a login. We actually really wanted to have it this year, but there's just not enough time to put out a quality product. Ideally, you would be able to manage all of your users in one single central system, and then you can manage all of the authentication that way, but that is not built in as of this time.
Is there any features around transaction searching and being able to stitch together transactions from various pieces of infrastructure and report on them?
It's a good question. I hesitate to say no because it may be feasible. You can really do advanced queries, but so I wouldn't say no. It looks like this gentleman may have.
So I was actually thinking about the same problem, and one way to do it.
Yeah, please.
So I was actually thinking about the same problem, and one way I'm thinking about doing it is use the Elasticsearch API, which I assume is the exact same API.
Yeah.
Okay, so I can sort of use that, do my queries to an event, stitch together my own stuff, and write it to a log file that I feed into Elasticsearch. So I'll write my own little scripts on top to correlate those events and use Lucene or the API to get that stuff fast.
You could do that, and one other thing that I will mention is if you know the parameters of certain events as they come in, on the Logstash input side, you can add filters. So if certain patterns are matched, you can tag, you can like add the equivalent of a tag or really any field that basically will say, these are all part of the same string of events. Then when you just search for that tag, or you filter down to the tag, it's only going to show you the elements that are within that tag. So that would accomplish it, but it takes some thought on the pre-side. You have to know that the events that are coming in are within, you know, a certain program or a certain element. One more.
One of the issues with Elasticsearch is the split brain problem. Does the logs, excuse me, have you guys tackled that issue?
So the question actually, just for those that aren't familiar with the split brain problem, what he's proposing is in Elasticsearch, because you have automated clustering going on, unless you set up a quorum of individual servers that have the ability or are eligible to become masters, you could have a case where if communication was lost, both of the clusters would come up, each electing themselves a master. There is an easy way to work around this if that in your environment you believe could be a problem. And we can assist you in setting it up, but basically we could spin up log server instances, set a couple parameters to make them only master only. Like, so there, you could bring up an instance, it doesn't store data. And to that end, being you've all seen what we're kind of coming out with a pricing structure, we're only pricing based on instances that store data. So if we help you spin up your 3 masters that are going to be in your quorum, they control what's going on, but they won't store any data, you wouldn't pay for them. You would just need 3 small lightweight systems that could act as your quorum, and then nobody would be elected master, you know, if there wasn't a quorum.
Have you deployed or tested deployment of clustering for Log Server in either Amazon or Azure?
Haven't tested it yet. I don't believe that it should be an issue at all because we don't use the broadcast configuration. You have to know an IP of another machine in your cluster. So it should work straight away as long as you've like in AWS, if you have the appropriate security groups open, so you have like ports, the appropriate ports open. It shouldn't be a problem. It should deploy straight away. But to be honest, I haven't deployed it. That's one of my projects that I do for all of our other products is make pre-installed images for Amazon, and so we'll probably be deploying that within the month. So you'll be able to just click a button and then to add another one, you just start another instance, and away you go.
All right, guys, this will be the last question of the Q&A. We are about out of time.
Is Fusion free only?
Pardon me?
Fusion is free only with the Fusion?
I guess I'm sorry, I don't understand the question.
I see the product in the Fusion.
Yep.
Fusion server.
Oh, okay.
It's free only?
It's not integrated with Fusion directly. However, we will have integration with like XI or Core, and from Fusion you can get into that. Would be a good component to be able to add into Fusion. We could probably get something like that developed in the near future. All right, well, I'd like to thank everybody for attending today's session.
Ladies and gentlemen, put your hands together for Scott one more time.